Hello everyone, good evening. I hope you all are fine there. So please tell me about audio and video, whether audio and video is clear or not. From my side it's clear. From my side it's clear. So guys, today we have one session on control system and it is in the continuity of the previous session. So in previous session we discussed about state equation, how to find state equation from differential equation. Okay, that we have covered. Now we will continue from that part only. Okay, so in today's session we will more discuss about solution of state equation and state transition matrix e to the power at. Okay, so we will discuss about that, how to find e to the power at. So we will discuss about state transition matrix. Okay, and let's see how it goes. I hope you will enjoy it. Okay, so guys, let's start the session. So this is my introduction. Let's first cover the introduction part and then we'll start the session. Okay, so this is my introduction and I will teach you each and almost every subject in electrical engineering, and so you can join with me, you can join BYJU'S exam prep and you can start your preparation with me. Okay, this is about a scholarship test. So it will be on 14th of May at 12 p.m. So you can register for this scholarship test, guys, and you can avail the scholarship up to 90%. So if you want to get, if you want to join BYJU'S exam prep, subscribe it, register it. The link is given in the description. Okay, this is about result. So this time, GATE 2023, BYJU'S produced top 62 ranks under 50 and 13 rank under 10 and under 100 107 rank. Okay, so this is all about results. Now it's time for the Guru Dakshina, and you have to give Guru Dakshina at the starting of the lecture. You have to subscribe our channel and press the bell icon so that you get the notification. Don't forget to like this video. Okay, so guys, let's start with the solution of state equation. In the previous class I discussed you how to calculate the solution using Laplace transform, if you remember. Okay, let's do it again. I told you that the state equation is like this: xt dot is equal to axt plus brt. Rt is my input, xt was state variable, and okay, so this xt dot is first derivative of xt. It means using this equation we can say that this equation says how this xt is changing with time. What is the rate of change of xt? So from this equation you can calculate xt at any time t. What is the value of state variable? So this represents the state transition. State variable depends on the present state variable and input. Okay, so you can see that this is my state equation. Now sometimes what happens, you take zero input. So let's first take the zero input. If rt is 0, let's put rt equal to 0. If let's say there is no input, then how the state variable will change? Because of the initial condition of the state variable in the system, because of the initial state variable, after some time t, the values of the state variable will change because the system will work, because the initial state variable will act like input. Okay, because sometimes it happens that there is no input, still you get the output. Why? Because of the initial value of the state variable. They must have some initial value. Okay, let's say there is a circuit in which inductor and capacitor is there. So in inductor there is a stored current and in capacitor there is a stored voltage. So we call them initial state variable. So because of those initial values, current will flow in the circuit. Okay, so I hope you understood what is the meaning of initial state variable. So let's say there is no input. If I take rt equal to 0, then the state equation will look like xt dot is equal to axt. This will be my state equation and rt is 0. Now we need to check what is the solution of this. In the previous class I told you that you can solve this using Laplace transform. So let's try this using Laplace transform. If I take Laplace on both sides, it will become sxs minus x of 0 is equal to axs. Now take this xs on the left side and take this x0 on the right side. So it will become sxs minus axs is equal to x of 0. Now you can take this x as common, so it will become SI, S identity minus A into xs is equal to x of 0. Now what is this xs? How to calculate xs? You can pre-multiply on both sides with the inverse of this matrix. So from here you can see that xs will be equal to Si minus A inverse into x of 0. Now in time domain, let's say you write this equation in time domain, so it will become e to the power 80 x of 0. Now you can see that the solution of this equation is this. It means from the initial state variable, you are transitioning to state variable at some time t. It means this is a state transition equation. You can say that it's a state transition equation. There is a transition from initial state variable to the state variable at some time t. Now you call this matrix as state transition matrix phi t. Okay, so you can also write it xt is equal to phi t into x of 0. This phi t is known as state transition matrix. So now we will discuss how to calculate this phi t. Okay, phi t is state transition matrix. It will tell you about state transition matrix. Okay, this is my phi t. It's also called e to the power 80. Now how to calculate this e to the power 80? There are multiple ways to calculate this e to the power 80. So in this class we will discuss about calculation of e to the power 80. There are multiple ways. One is using Laplace. Using Laplace. This is the most popular method. Using Laplace transform. Okay, using Laplace transform. This is first method and most popular method. Maximum student do it like this. Even maximum teacher do it like this. But there are multiple ways to calculate e to the power 80. One method is using eigenvalues and eigenvector. Using eigenvalues and eigenvector. If you know how to calculate eigenvalues and eigenvector, you can apply this method also. I will tell you how to calculate e to the power 80 using eigenvalues and eigenvector. Number 3, using Sylvester interpolation method. There is one more method, Sylvester interpolation method. So there can be multiple ways to calculate e to the power 80. There are 3 ways. I am telling you these 3 ways to calculate e to the power 80. Using Laplace transform, using eigenvalues and eigenvector, and Sylvester interpolation method. Now let's try this. First, let's try using Laplace transform. For that, I have to take some question. Let's say some A matrix is given to you. A is given to you as -1, 0, -3, -2. Let's say this is my A matrix. Now for this A matrix, we need to find e to the power 80. How to find it? We know that e to the power 80 is equal to Laplace inverse of Si minus A inverse. Okay, Laplace inverse of Si minus A inverse is known as e to the power 80. So we have to calculate that e to the power 80. Now how to calculate? First we have to calculate Si minus A. So if I write S into identity minus A, then this will be equal to S plus 1, 0, 3S plus 2. Okay, this is Si minus A. Si minus this A matrix. This will be the Si minus A. Now we need to calculate Si minus A inverse. We need to calculate the inverse of this. To calculate the inverse of this, I have to take the determinant and I have to write the determinant in the denominator. So S plus 1 into S plus 2. So this is the determinant of this matrix. I have written this in the denominator. Now you have to interchange the principal diagonal element and change the sign of the off diagonal elements. Okay, so this is the inverse of this. Now let's take it inside. So if you take it inside, then you will get Si minus A inverse, that will be equal to, take this determinant inside. So if you take this determinant inside, then you will get this S plus 2 will cancel. So here you will get 1 over S plus 1. Here you will get 0. Here you will get -3 divided by S plus 1 into s plus 2, and here you will get 1 over s plus 2. Now what you need to do is, to find e to the power 80, you have to take the Laplace inverse of this. So let's take the Laplace inverse of this quantity. So if you take Laplace inverse of this quantity, you'll get e to the power 80. Now can you tell me what is the Laplace inverse of this quantity? E to the power minus t, ut. So let's not write ut for the time being. Okay, and this will be 0. What is the Laplace inverse of this? E to the power minus 2t. Now what is the Laplace transform of this? So you have to apply the partial fraction. If you apply partial fraction, so first you can write it like this: a over s plus 1 plus b over s plus 2. Now you can calculate the value of a and b. What is the value of a? Value of a is minus 3. And what is the value of b? Value of b is plus 3. Okay, so you can apply the partial fraction, and using partial fraction you can say that it will be minus 3, it will be plus 3. Okay, and if you take Laplace inverse, you'll get minus 3 e to the power minus t plus 3 e to the power minus 2t. Okay, so this will be my e to the power 80. This way we can calculate e to the power 80. It's easy peasy. Okay, using Laplace transform you can calculate e to the power 80. State transition matrix you can calculate using Laplace transform. It's very simple. Now what is this Sylvester interpolation method? Let's first discuss this method, and at last we will come to eigenvalue and eigenvector method. Okay, now we need to understand how to find e to the power 80 using Sylvester interpolation method. Using Sylvester interpolation method, okay, SI method, Sylvester interpolation method. What is this method, guys? Using this method also you can calculate eigenvalues. You can calculate e to the power 80. Now how to do that? First of all, for distinct eigenvalues, let's discuss for distinct eigenvalues. Distinct eigenvalues. Let's say you have distinct eigenvalues. Now in this question, if you know how to calculate eigenvalues, then you can easily say that it's a lower triangular matrix, and the eigenvalues of this matrix is minus 1 and minus 2. Okay, these are the eigenvalues, guys. If you know the eigenvalues, these principal diagonal element, because it's a lower triangular matrix, whenever you have lower triangular matrix, the element on the principal diagonal are called eigenvalues. So if you find these eigenvalues, you can use interpolation method. Okay, Sylvester interpolation method to find e to the power 80. Now how to do that? It's very simple. If you have distinct eigenvalues, then what you need to do is 1 lambda 1 e to the power lambda 1t, 1 lambda 2 e to the power lambda 2t, identity A matrix e to the power 80, and put this determinant equal to 0. Okay, remember this. For 2 by 2 matrix, you have to find this determinant and put it equal to 0. This is known as Sylvester interpolation method. Now, when this method is used, whenever you have distinct eigenvalues, if you have distinct eigenvalues, you can use this. Now, let's put these values of lambda 1, lambda 2. If I put these values of lambda 1, lambda 2, you can see that it will be 1, minus 1. First eigenvalue is minus 1, we know that. Okay, minus 1. And this will be e to the power minus t. Now, 1, next minus 2, e to the power minus 2t. And next is identity A matrix, and this is e to the power 80. Okay, and put it equal to 0. This determinant must be equal to 0. You can make this determinant equal to 0. Okay, now I need to calculate this determinant. And using the determinant of this matrix, you can calculate e to the power 80. Now how to do that? It's simple. Let's find the determinant along this row. Okay, along this row, if I find the determinant, then you will get 1 into minus 2 into e to the power 80 minus a e to the power minus 2t. Okay, now plus 1 into, tell me, e to the power 80 minus identity into e to the power minus 2t. Okay, plus e to the power minus t into a plus 2 identity, and put it equal to 0. Okay, so what we have done is we have found the determinant of this matrix, and determinant of this matrix is very simple. You can expand it with respect to this row, and you will get like this. Now let's simplify it. So this is minus 2 e to the power minus 2 e to the power 80, and this is e to the power 80. So if you combine these two terms, you will get minus of e to the power at. Now let's combine this term and this term. You can see that it is negative, it is also negative. So you can take this negative common and e to the power minus 2t common. So now you will have a plus identity. A plus identity. You can see that I have taken this minus common and e to the power minus 2t and minus 2t taken common. So you'll get a here and identity here. Okay. Now plus e to the power minus t into 2 plus what is this? Wait a minute. A plus, this should be wrong actually. Okay. If you take e to the power minus t, then it should be a plus 2 identity. A plus 2 identity. Okay. So this must be a plus 2 identity. This has to be a plus 2 identity. Okay. And make it equal to 0. Is it clear, guys? Now take this minus e to the power at on this side. So if I take this minus e to the power at on the right side, so on this side now you have e to the power at. It will become positive. So e to the power at has to be this value. So you have to calculate this value. Okay, you have to calculate this value to find e to the power at. It's simple. Okay, it's very simple. You need to calculate the determinant of this matrix. Okay, and using the determinant you can calculate that. Now let's try to solve this question. So if I want to solve this question, you have to put the value of a plus identity and a plus 2 identity, and you have to multiply with e to the power minus 2t. Let's do it. So a plus identity, what is a matrix? A matrix is this. I have to add identity to it. Okay, so if you add identity to it, then a plus identity matrix, let me write minus e to the power minus 2t into a plus identity. A is this matrix. If I add identity, it will become 0 0 minus 3 minus 1. Okay, 0 0 minus 3 minus 1. This is a plus identity. This is a plus identity. Okay, this is a. I have added identity to it. Now a plus 2 identity. If I add a plus 2 identity, then it will become 1 here, 0 minus 3 and 0. Okay, so it will become 1 here, 0 minus 3 and 0. This is a plus 2 identity. You can see that this is my a matrix. I have added 2 identity to it. Okay, so I have added 2 here and 2 here. So it will become plus 1 0 minus 3 0. Okay, plus 1 0 minus 3 0. And what I have done, a plus 2 identity into e to the power minus t I have to take. Okay, e to the power minus t I have to take, and then I have to add it to get e to the power at. So it's simple. I have put the value of a plus identity and a plus 2 identity and multiplied by this and this. You can see that. Okay, now let's combine it. If you combine it, you'll get e to the power at will be equal to the first element. You can see that 0 here. This into 0 is 0 plus e to the power minus t. So you'll get e to the power minus t. Now the second element, 0 here and 0 here. You'll get 0. Now here you can see that it will be 3 e to the power minus 2t, and here you are getting minus 3 e to the power minus t. Okay. Now here you are getting e to the power minus 2t. Okay. So you can see that you will get e to the power at like this. Previously also, if you have used Laplace, you are getting the same answer. You can see that. Okay, you are getting the same answer, and from this method also you are getting the same answer. So you can apply this method also, Sylvester interpolation method or the Laplace transform method. Okay, so both are easy, and using both methods you can solve. Now there is one more method to find e to the power at using eigenvalues and eigenvector. Okay, let's try to do it. Okay, let's say a question is given to you. Let's say a question is given to you that we have a state equation x dot t equal to axt, and the eigenvalues of a, eigenvalues and eigenvector, eigenvalues and eigenvector are given as, so eigenvalues and eigenvector are provided to us minus 1 comma 1 1, minus 2 comma minus 1 minus 2. Let's say these are the eigenvalues and eigenvector. They are provided to us. Find e to the power at. We need to find e to the power at. Now how to find e to the power at now? It's a very good question. How to find e to the power 80? You can find e to the power 80 in easy way. There can be multiple way to find e to the power 80 from this situation. First, you can find a from here, and then once you get this a, then you can find e to the power 80. Or there is one more method. You can directly find e to the power 80. And what is that method? What is that method? E to the power 80 will be equal to s e to the power lambda t S inverse. Now, what is this S matrix? And what is this S inverse matrix? And what is this e to the power lambda t matrix? Okay, lambda is known as diagonal matrix. Diagonal matrix. Now, how to find this lambda? It's very simple. On the principal diagonal, you put these eigenvalues, -1, 0, 0, -2. Okay, so this is my diagonal matrix, lambda. Okay, now what is e to the power lambda t? So e to the power lambda t will be equal to e to the power minus t, 0, 0, e to the power minus 2t. Okay, this is my e to the power lambda t. It's simple. So we have calculated e to the power lambda t. Now what is this S matrix? This S matrix is the eigenvector matrix. S is known as eigenvector matrix. Eigenvector matrix. S is known as eigenvector matrix. Now how to find it? It's very simple. In every row, you put these vectors. In first row, because you have shown this as first element, so the first column has to be 1, 1. Excuse me, I said this in every row. In every column you have to write. In every column you have to write these eigenvector. In the first column you have to write 1, 1. In the second column you have to write -1, -2. This is my eigenvector matrix S. Now what is S inverse? You have to take the inverse of this. How to take the inverse? Find the determinant. So determinant is -2 plus 1. So it's -1. So 1 upon -1. And now interchange these values and change the sign of this 1 and -1. Okay, now take this -1 inside, so you'll get 2 here, -1 here, 1 here, and -1 here. Okay, so this is my S inverse, this is my S matrix, this is S inverse. You can put these values, you know this S matrix, you know this e to the power 80, and you know this S inverse matrix, and you can calculate e to the power 80. I hope it is clear to you. So this way also you can calculate e to the power 80. Let's calculate e to the power 80. So e to the power 80 will be equal to S. What is S matrix? What is S matrix? S matrix is 1, -1, 1, -2. 1, -1, 1, -2. Now what is e to the power 80? E to the power lambda t. So this is my e to the power lambda t. We have already calculated that. Okay. Now S inverse. S inverse is 2, 1, -1, -1. Okay. 2, 1, -1, -1. So you multiply these three matrices and you will get e to the power 80. It's simple, easy peasy. Okay. Now remember, this method is applicable if eigenvalues and eigenvector are given. If eigenvalues and eigenvector, if A is given, then you don't try to use this method. Because if A is provided to you, let's say A is given to you, then you can use Laplace method or interpolation method. Okay. You can use Laplace method or interpolation method. So don't use this method. But if A is not given, let's say eigenvalues and eigenvector are provided to you, then you can use this method to find e to the power 80. Because if eigenvalues and eigenvector are provided, then to find A is a lengthy process. You can do that also. First you need to find A. How to find A? If you know the eigenvalues and eigenvector, how to find A? It's simple. If eigenvalues and eigenvector are known, then A can be written as S lambda S inverse. You have to remember it. I'm not telling you the proof of this. Okay. So you have to remember it. So A will be equal to S lambda S inverse. Lambda means diagonal matrix. So it will be -1, 0, 0, -2. Let's say for the previous question, let's say for this question, you are finding A. Now how to find A? So to find A is very simple. So we know that lambda is this, S is eigenvector matrix. We already have done that. Okay. So A will be equal to, what is A? A will be equal to S. What is S? Let's first look at the S matrix. S matrix is this 1, -1, 1, -2. Okay. So 1, -1, 1, -2. This is S matrix into lambda. Lambda is -1, 0, 0, -2. This is lambda and S inverse. What is S inverse? You can see that S inverse is 2, -1, 1 minus 1, okay? 2 minus 1, 1 minus 1. Now you can find A. Once you get this A, then you can find e to the power at using Laplace transform or using interpolation method. You can use that, but it's a lengthy process. It's a lengthy process, okay? It's a lengthy process. I hope you got it. This is a lengthy process. That's why you can directly find e to the power at like this. Using this equation, you can directly find e to the power at. I hope it is clear. I hope this method is clear to you. So there are three methods to find eigenvalue and eigenvector, to find e to the power at, okay? And what are those methods? Using Laplace transform you can find. Using Laplace transform, I told you, you have to find e to the power at will be equal to Laplace inverse of Si minus A inverse, okay? Using this you can find it. Now, using eigenvalues and eigenvector, e to the power at will be equal to S e to the power lambda t S inverse. You can find e to the power at like this. And there is in Sylvester interpolation method. You have to find the determinant 1 lambda 1 e to the power lambda 1t, 1 lambda 2 e to the power lambda 2t, and this is valid for 2 by 2. Now for 3 by 3 I have to change it. I mean Sylvester interpolation method is also valid for 3 by 3 or 4 by 4, whatever. It is also applicable, but then I have to change it. But I don't want to tell you about that because at max they will ask you up to 2 by 2 matrix only, okay? As far as gate is concerned, they will not ask you about 3 by 3 matrix. They may ask you for 2 by 2. Now there is, let me tell you one more point. If the eigenvalues are repeated, if the same eigenvalue is repeated, then this method you have to modify this matrix, okay? I don't want to tell you about that. When the repeated eigenvalues are there, then you can't use this method, okay? I mean you can use this method, but you have to modify this matrix, okay? You have to modify this matrix if lambda 1 and lambda 2 are equal, let's say. Similarly, this also you can't use it directly. You have to modify it. There you need to get diagonal Jordan matrix. In place of this diagonal matrix, you have Jordan matrix, okay? So I'm not going to tell you about that. When you have repeated eigenvalues, let's say you have distinct eigenvalues. So specially I'm telling you about distinct eigenvalues. Distinct eigenvalues. Laplace method is applicable everywhere. I mean, whether the eigenvalues are distinct or repeated, you can always apply this. You can always apply this method also or this method also, but the problem is if the eigenvalues are repeated, then in place of this diagonal matrix you have Jordan matrix, okay? Now what is the Jordan matrix? We'll see that, okay? Not in this class. And similarly, Sylvester interpolation method, again it is also applicable for repeated eigenvalues, but then you have to modify this, and I don't want to go into that because that's not for you can say in this class. I don't want to tell you. Maybe some other class I'll tell you, okay? So for distinct eigenvalues you can use these methods to solve for e to the power at. Now what are the properties of e to the power at? Now let's come to properties of e to the power at. Properties of e to the power at, or you can say phi t, state transition matrix. What are the properties, okay? So if you want to go get the properties, then the first property is the first one, phi of 0. If you put t equal to 0, then it has to be identity matrix. It means the state transition matrix at t equal to 0, it has to be 1, identity. You can see that we have already calculated some state transition. Yes, this was e to the power at. Any e to the power at, if you put t equal to 0, it will become identity. You can see that. Okay, if you put t equal to 0, it must be an identity matrix. So this is the first property, or you can directly remember it. If you put t equal to 0 on both sides, it will become e to the power 0. E to the power 0 is 1. 1 means in matrix form identity. Okay, so this is the first rule. Phi of 0 has to be equal to identity matrix. Now number 2, if I take phi of t to the power k, you can also write it phi of kt. Okay, you can also write it phi of kt. This is again very important property for for state transition matrix. You can see that if I put both sides, if I take power k, then this will be multiplied with k, t will be multiplied with k, so that's why it will become kt. Now this is a very useful property. How it is useful? What you can do is you can put k as -1. So if you want to take inverse of state transition matrix, then it's very easy. You replace t with -t. In phi t, you replace t with -t, you'll get the inverse of phi t. It's easy peasy, okay? So it's simple. Similarly, if you want to calculate the square of the phi t, let's say you want to calculate the square of state transition matrix, it will become phi of 2t. Simple. It will become phi of 2t. So it's very simple. Okay, I hope you understood the properties of these properties of state transition. Now number 3. If you calculate the derivative of e to the power at, derivative of phi t, and if you put t equal to 0 in that, you will get A. You will get A matrix. It means from e to the power at matrix, let's say e to the power at is provided to you. Now how to find A matrix? It's very easy. You take the derivative of this, whatever e to the power at is this. Let's say e to the power at is this. This is my e to the power at, and we need to find A. We need to find A matrix, this matrix A. This matrix A we need to find. So what you can do is, you can take the derivative of the elements of these e to the power at. Let's take the derivative. So it will be minus of e to the power minus t. We have to take the derivative with respect to t. So it will be minus 1 e to the power minus t. This will be 0. Here you will get minus 6 e to the power minus 2t and plus 3 e to the power minus t. Okay. Here you will get minus 2 e to the power minus 2t. Okay. Now in this derivative matrix, you put t equal to 0. If you put t equal to 0, you will get minus 1 here, 0 here, minus 3 here, and minus 2 here. This will be equal to A. So this way you can find the matrix A. I hope it is easy peasy. Okay, so you remember, this is a very interesting property. Property number 3. Okay, so you have to remember how to calculate A matrix. Number 4 property. Property number 4. Sometime what happens? Let's say you have a state variable at some time t naught, and you want to reach to some time at some, you want to calculate the value at some time t3. So what you can do is, you can multiply this with this matrix. Okay, it means in phi t you place t3 minus t naught. If you have t3 minus t naught, what this signifies? It signifies that there is a transition from t naught to t3. It means this x t naught, this t naught state variable, the state variable value at time t equal to t naught, it is transitioning from t naught time to t3 time. You can calculate x of t3. I hope it is clear. Similarly, you can break it. You can break it also. X of t naught into phi of t1 minus t naught into phi of t2 minus t1 into phi of t3 minus t1. T3 minus T2, okay? T3 minus T2, and you will get x of T3. You'll get x of T3. I hope it is clear, guys. You'll get x of T3. So you can see that this is the state variable at t equal to t naught. So it is transitioning from t naught to t1. So this multiplication will give you x of t1. Now this is doing the transition from t1 to t2. So it will give you x of t2. It will give you x of t2. It means state variable at time t2. Now this t2 minus t3 is again multiplied, so it will give you a state variable at x of t3. At x of t3. So it means you can make it in steps. Okay, you can calculate the state the value of the state variable at some other time t3, and you can also make it in steps. Okay, I hope it is clear. Property number 4. Now let's come to property number 5. Property number 5 says it's a bilateral process. It's a bilateral process. Property number 5. State transition is a bilateral process. What does it mean? It means you can go from 0 to t and t to 0. You can come back. Okay. We know that xt is equal to e to the power at into x of 0. Now what you can do is, from this state to this state you can come. What you need to do is, you need to multiply with the inverse of this. E to the power at, whatever the inverse, you just multiply on both sides. Okay, that will be equal to x of 0. And we know that the inverse of this state transition matrix is phi of minus t. You replace t with minus t. Okay, and you will get x of 0. So there is a transition in backward direction. You can see that. Okay, state variable at some time t is provided to you, and you want the state variable at t equal to 0, let's say. So there is a backward transition. So you can do backward transition by multiplying phi of minus t with it. Okay, I hope it is clear, guys. I hope this is clear. So this is again bilateral property of state transition matrix. Okay, so these are the properties that you need to remember, and you need to apply these properties in questions. Okay, so I have revised the properties of e to the power at also. So this lecture is very important as far as these properties are concerned, because sometime the question came that which of the matrix represent the state transition matrix. Now you have to check whether this matrix represents state transition matrix or not. How to check it? You have to check the properties. First property is, if you put t equal to 0, this matrix has to be identity matrix. If it is becoming identity, it means it is this matrix hold this identity property. Okay. Now the next property is, if you take the inverse of this matrix and if you replace t with minus t, you must get the same answer. Okay. If you replace t with minus t and if you take the inverse of this matrix, they must be same. Okay, so you can check these two properties to find whether this matrix represents a state transition matrix or not. Okay, so this way you can check. So these properties are very important, guys. You have to remember these properties also. And I told you how to find e to the power at and what are the properties of e to the power at. Okay, so that's all for today's session. I hope you enjoyed this session. This session was again very important. Okay, so let's stop it here. This type of session will come in future also. Okay, so I hope you learned some new things in this session. So don't forget to subscribe our channel and don't forget to like this session, guys. So please like it, press the bell icon if you have not pressed it, and subscribe our channel. We have our mobile app, BYJU'S Exam Prep mobile app. So you can install this mobile app from Google Play Store, and there also you can watch free lectures. There are so much free lectures on concept building, on numericals. Okay, so you can attend those lectures. Even I myself also take free lectures on mobile app. So you can install this mobile app and get benefited. Okay, so that's all for today's session, guys. Thank you for showing interest in this class. See you in the next class. Take care. Bye.